with the European Space Agency, with ongoing access to the combined observational data for 3I Atlas. For months, I have been part of a formal working group that has tried and failed to reconcile this object's behavior with any known class of natural celestial body. The official position is that 3I Atlas is a uniquely active but otherwise natural comet. This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue for a growing number of us.
3I Atlas has been under quiet observation for months within a European research network. Its behavior recorded, checked, and rechecked across multiple instruments. Each new dataset made less sense than the last. The official line held that it was a comet, active, volatile, but natural. Yet the numbers told a different story. The object's emissions, motion, and energy balance didn't just challenge models, they mocked them. To reconcile its behavior with known physics required a suspension of disbelief that no one wanted to admit aloud. The deeper the investigation went, the clearer it became that something was wrong, not with the instruments, but with the universe they were designed to measure. The readings were irrefutable. The object was shedding roughly 150 kilograms of gas and dust every second, a constant roaring exhalation across the void. It was the kind of energetic outburst that should have produced recoil, visible motion, or at least measurable turbulence. Instead, there was nothing. The object remained eerily still, drifting forward without the faintest wobble or spin. It was as though a howitzer could fire without recoil, as though energy could be released without consequence. Each observation repeated the same paradox, a violent event with no measurable reaction. Whatever this thing was, it appeared to operate outside the transactional logic of force and resistance. It expelled matter into space, and space simply ignored it. Attempts to resolve the anomaly by adjusting the object's mass only deepened the absurdity. Calculations suggested it possessed the weight of a small moon, compressed into a body scarcely 3 kilometers wide, a density that defied both theory and probability. If accurate, such a concentration of matter should have shattered long before it reached the solar system. Even worse, the odds of discovering something that massive so early in our interstellar survey efforts were practically zero. The statistical models said there shouldn't be one 3I Atlas in a million galaxies, yet here it was, undeniable, radiant, and silent. The possibilities narrowed to two. Either our understanding of how matter is ejected from solar systems was catastrophically wrong, or this object was never debris to begin with. The deeper the investigation went, the less the universe seemed to cooperate. The object was analyzed spectroscopically, and its chemistry only multiplied the confusion. The gases streaming from its surface contained atomic nickel, a substance that should have been frozen solid in the frigid vacuum it occupied, yet it vaporized in violent bursts, responding not gradually but in binary pulses, as though flipping between two stable states. When the light from the sun increased slightly, the nickel vanished. When it dimmed, the signal returned. There was no thermal transition curve, only an on-off switch. The only chemical compound capable of producing that effect was nickel tetracarbonyl, a synthetic toxic gas used in industrial metal refining on Earth. Its existence on a natural body, one that had supposedly wandered the galaxy for billions of years, was inconceivable. The findings did not merely stretch probability, they tore it apart. If the composition was unbelievable, the dust it shed bordered on heretical. Polarization studies of the light scattered by those particles showed a texture unlike any other cometary dust ever measured. Instead of the granular, icy mixture familiar to astronomers, the particles were dark, porous, and intricately structured, almost carbon black and feather light. They absorbed light rather than reflected it, and their scattering patterns suggested a manufactured complexity. It was as if the dust were not eroded rock, but the residue of a process, something burned, condensed, and expelled. The numbers were checked, then rechecked. Instruments were recalibrated, the data held steady. It was not natural dust, not the byproduct of a frozen world thawing in the sun. Whatever it was, it belonged to a category that did not yet exist in the catalogs of planetary science. It was a system of wrongness, elegant in its precision. The next revelation came from space-based observations. Both Hubble and the James Webb Space Telescope observed a faint, oily tail extending away from the object, not trailing behind it, but pointing directly toward the sun. The implication was immediate and unsettling. For the tail to behave that way, there had to be a massive jet of carbon dioxide erupting from its sunward side, powerful enough to push against solar radiation and eject heavy ice grains backward. But the object didn't spin. In every frame, its brightness remained a perfect constant, with no variation whatsoever. Astronomers expect active bodies to pulse and flicker as they rotate, their illuminated sides waxing and waning like a heartbeat. Here, there was only stillness. A jet powerful enough to generate such a tail should have produced a rhythmic oscillation. Instead, the light curve was as flat as a deadline on a monitor. Either the tail was an illusion, or the object had found a way to vent matter in a directionless, perfectly uniform flow. Both options defied known mechanics. Its temperature made even less sense. Bathed in solar radiation, it should have been boiling, a superheated engine throwing off plumes of vapor. Yet it remained cold, stable, and indifferent. The energy pouring into it each second would have vaporized ordinary ice instantly, but the object's surface showed no change. It absorbed heat and simply refused to respond. The energy vanished into some unseen process or passed through it entirely. It was like holding a torch to an iceberg that refused to melt. And as it journeyed closer to the sun, that impossible equilibrium persisted. The heat did not build. The mass loss did not accelerate. The chemistry did not evolve. The object remained the same, an unyielding, silent equilibrium surrounded by a cloud of impossibility. Even its trajectory mocked the odds. The orbit was a perfect arc, a low angular momentum path that guaranteed a close pass through the heart of the solar system. The mathematics of celestial probability insisted this could not happen by chance. There was no known process capable of filtering interstellar debris onto such precision courses. To find one object so ideally aligned so swiftly after beginning to search for them was a statistical miracle. To believe it was random required an act of faith greater than any scientific hypothesis could justify. There was only one remaining explanation that made sense, and it was the most terrifying of all. The object had been delivered. The contradictions accumulated like equations approaching singularity. A jet without recoil, heat without melting, outgassing without spin, perfect trajectory without randomness. None of it could be separated. Each paradox depended on the others. Together, they formed a single, coherent portrait of impossibility, as though the universe itself were revealing a hidden architecture beneath its surface. What looked like noise began to resemble design. This wasn't a failure of observation or an error in theory. It was a window into something deeper. The laws were not breaking. They were being rewritten. The framework that emerged was almost heretical in its simplicity, elegant, terrifying, and for some inevitable. The object it was proposed was not a comet, nor even a fragment of any known material body. It was something far older and stranger, a macroscopic quantum structure, a physical relic from the universe's earliest heartbeat. In the first microseconds after the Big Bang, when matter and energy were still struggling to define each other, the laws of physics did not yet resemble the ones that now govern stars and planets. In that chaos, it was theorized, certain exotic configurations of fundamental fields could have stabilized, tiny knots in space-time itself, bound not by atoms, but by the equations of quantum potential. 3I Atlas, according to this view, might be one of those survivors, a fossil from before the universe cooled enough to form hydrogen. In theoretical physics, such an entity has a name, a cue ball. It is what's known as a non-topological soliton, a kind of standing wave made of matter, self-contained and perfectly stable, protected by conservation laws that do not apply to ordinary particles. Unlike stars or planets, a cue ball would not rely on fusion or chemical reactions to maintain its structure. It would be a vast, coherent field, a single quantum object stretched across kilometers, perhaps billions of times more massive than any molecule, yet still ruled by the mathematics of subatomic behavior. Within it, the familiar boundaries between matter and energy blur. It would pulse with internal currents of quantum charge, generating its own gravitational skin, sealed from the outside world by a thin boundary where its reality and ours collide. Such an object would not obey the thermodynamics of normal matter because it was never made of normal matter. It would not melt, crack, or ignite. Its temperature would remain constant across eons because the energy flowing through it would already be in perfect balance. It would not react to the sun's heat any more than a thought reacts to fire. Its power would come from its own slow decay, its interior fields bleeding energy outward in a perfectly symmetrical drift. The gas and dust that telescopes saw streaming away would not be cometary exhaust at all, but the byproducts of that eternal internal reaction. The quiet exhalations of a machine that was never built, only born. And because the process was isotropic, equal in every direction, there would be no recoil, no spin, no flicker. The object would move through space like a ghostly equilibrium, shedding matter without losing momentum, radiating energy without growing warmer, changing constantly yet never evolving. It would be a closed system in every sense, a self-sustaining reactor powered not by combustion or collapse, but by the slow and deliberate evaporation of its own quantum order. From a distance, it would look like a comet, bright, cold, and silent, but inside, it would be the most perfect kind of storm, a stable knot of pre-cosmic physics masquerading as a rock.
In that interpretation, every mystery fell neatly into place. The dust became slag, the waste of a furnace burning on laws older than stars. The unchanging temperature was not regulation, but indifference, the product of a system whose energy scale dwarfed the sun's influence. The apparent stillness was the equilibrium of an entity balanced against itself. Its trajectory ceased to be an accident and became something inevitable. Objects like it, if they existed, would not be rare intruders but the unseen scaffolding of the galaxy, dark matter itself, clothed in invisibility until a passing star briefly revealed their outline. If 3i Atlas truly belonged to that hidden order, then it was not an interloper from another world, but a survivor from another kind of universe. The implications rippled outward faster than light could travel. If this was real, then the cosmos was full of such engines, ancient and uncountable, drifting silently through the void. The fossils of creation, operating on principles we have yet to name. The object was no longer a curiosity, but a revelation, a whisper from the foundation of everything disguised as a comet. And yet, amid all the speculation, the method of verification remained elegantly simple. If the object's brightness and activity continued as it receded into the dark, if it refused to fade like every other comet, then the theory would gain weight. If its internal processes emitted even a trace of gamma radiation, a faint, steady pulse divorced from solar wind or reflection, then the impossible would step into the realm of the real. The data would either vindicate or bury the theory. All the universe had to do was keep shining, or not. Beyond the numbers and the theories, one truth remained. Something ancient and inexplicable had passed through our system, silent and unyielding, carrying with it the residue of forgotten physics. It absorbed our light, defied our expectations, and then slipped back into the dark. Whether it was debris, a relic, or a quantum survivor from the dawn of time, it left behind a singular question. Not about what it was, but about what else might be drifting out there waiting to remind us that the universe still contains secrets vast enough to silence even the boldest of equations.